Final exam review, part 1. Number 1. Consider the following right triangle. A. Determine the length of the unknown side. For any right triangle, if you knew the lengths of two sides, any two sides, you can find the length of the third side by using the Pythagorean theorem. That is, a squared plus b squared equals c squared. Now, side C is always the side opposite the right angle. So in this case, C has to be 26. Doesn't matter for the other sides which side is A and which side is B. All right, so I'll make the substitutions. I'll leave A as a variable, since that's what we want to find, plus B squared, that'll be 24 squared, equals C squared. That's 26 squared. So A squared plus now 24 squared, that's 576, equal 26 squared, that's 676. So I'll solve for A squared. I'll subtract the 576 from both sides. So I have A squared is equal to 100. So A would be the square root of 100, or 10. So 10 units. For B, we want the perimeter of the triangle. So the perimeter is just the distance around the exterior of that triangle. So I can find that just by adding the lengths of side A plus side B plus side C. So A we found to be 10, B is 24, C is 26, so we get a total of 60 units. For 2, we want to determine the shaded area of each of the following figures. For the first figure, for A, we want to take the area of the trapezoid and, so here's our trapezoid, where we have one pair of parallel sides. And we're going to subtract the area of this triangle. All right, so for the trapezoid, the formula is 1/2 the height times the sum of the two bases. Well, the bases are the sides that are parallel. Now the height is the distance between the parallel sides, noting that that height has to form right angles with one of the bases. So the height is 4. So it's 1/2 times 4 times 6 plus 12. Gives me 36, and we're in inches, so for area it'll be square inches. Now for the triangle. The area is 1/2 the base times the height. So the important thing about a triangle is that the base and height have to form right angles. So if this is our base, then forming right angles, this would be our height. So if the base is 6 inches. The height is 4 inches. The area is 1/2 times 6 times 4, or 12. We're in area, so it'll be 12 square inches. So we said the area of the trapezoid is 36 inches squared minus the area of the triangle is 12 inches squared equals 24 inches squared. For B, to find the shaded area, we're going to take the area of the circle and we're going to subtract the area of this rectangle. So for the circle, the area is pi r squared. Now the radius, the circle's from the center, distance from the center to any one side, so the radius is 4. So it'll be pi times 4 squared. It gives us 50.265. I'm going to round this to the nearest 2 decimal places. So identify the digit in the hundredth position. The number directly to the right is 5 or more, so this will be 50.27, and we're in inches, so for area it'll be square inches. Now for a rectangle, the area is just length times width. So here, if our length is 5 inches, our width is 6 inches, our area is 30, it'll be square inches. So our area is 20.27 inches squared. Now for 3, we want to find the cone of the following figure. This cone, this figure is a cone, and the volume of the cone is 1/3 pi r squared h. So the r, or that's the radius of the circular bottom. Well, what they gave us was the distance from one edge through the center all over to the other. So they gave us a diameter. So the diameter is 8. So the radius will be half of that. So the radius will be 4. All right, the height from the highest point in our cone, we drop it down so it forms right angles with a circular base. We see that that's 12. So it's 1/3 times pi times 4 squared times 12. So I have 201.06. I'm going to round it to the nearest tenth. So I identify the digit in the 10th position. The number directly to the right is 5 or more, so 201.1. And we're in volume, so it'll be cubic units, so cubic feet. For 4, we want to determine the volume of the following figure. Well, this figure is a combination of a pyramid plus a rectangular solid. So, for the pyramid, well, pyramid plus rectangular solid. So for the pyramid, the volume is 1/3. Now this is a capital B, means the area of the base times the height. So in this case, our base, it's going to have the same base for the pyramid that we have for a rectangular solid. So it's a square. So that capital B is the area of a square. So to find the area of a square, it's the length of a side squared. See, the sides are each 4 inches. So capital B is going to be 4 squared, or 16. Now the height is just how tall that pyramid is. See, from the top down to the bottom, 6 inches. So it's 1/3 times the area of that base, that square base, times how tall the pyramid is, times 6. So I have 32, and we're in volume, so it'll be cubic units, so cubic inches. Now for a rectangular solid, volume is length times the width times the height. So if our length is 4 inches, our width is 4 inches, and our height is 5 inches. So 4 times 4 times 5 equals 80, and we're in volume, so it'll be cubic units, or in this case, cubic inches. So we want the whole figure. So I end up with 112 inches cubed. Five. Find the volume of the shaded regions in the following figure. So what we have is a cylinder and we're going to cut out 3 spheres. It's like a canister of tennis balls. So start with our cylinder. So our cylinder is pi r squared h. So the r is the radius of that circular bottom. What they gave us was the diameter, all the way across that circular bottom. So they gave us a diameter of 8 centimeters. The radius is half of that, so 4 centimeters. Now the height, it's just how tall a can is from the top all the way to the bottom. So it's 23.6. So pi times 4 squared times 23.6. So I have 1186.265. I want to round it to the nearest hundred, so I'll take it out 3 places. Identify the digit in the hundreds position. Look at the digit directly to the right. That's 5 or more, so this would be 1186.27. And this would be, we're in centimeters, so centimeters cubed. Now, let's do one sphere first. So the volume for one sphere can be found by taking 4/3 pi r cubed. Well, again, they gave us the diameter, the distance from one side of that sphere all the way over to the other side of the sphere. They give us a diameter of 7.8 centimeters. So the radius is half of that, or 3.9 centimeters. So 4/3 pi times 3.9 cubed. That would be the volume of one sphere. But if we want the volume of 3 spheres, I want 3 times that. So 3 times the volume of one sphere. So if I wanted to, I could just say the 3, and that 3 cancels, and just multiply 4 times pi times the 3.9 cubed. So I get 745.424. Rounded to the nearest hundredth, so I'll identify the digit in the hundredth position. The number to the right is less than 5, so 745.42. And we're in centimeters, so centimeters cubed. So we want to take the volume of the cylinder and cut out the volume of the 3 spheres. So I have 440.85, and it'll be in cubic centimeters.